or are you doing this best practice? But today, let's just take a deep dive into something more fundamental.
Okay, I like it.
Let's talk about cognitive load and how it impacts us, as developers. And to help us with this, we're going to be looking at this awesome source called Cognitive Load is What Matters,
Yeah.
which it's funny. This actually started like as a Reddit post and just kind of blew up, and it's evolved into this living document. I mean, tons of people have contributed to it. So,
And it's such a great resource
Yeah.
because it gets to like the core of what it takes mentally to work with code and understand code. And the interesting thing is that a lot of this cognitive load is extraneous. Like it's stuff we can actually control. We can reduce it through better decisions.
yeah, it's like all the stuff we're doing that's making it harder on ourselves than it needs to be.
Really, yeah.
So, for everyone listening, like imagine cognitive load is like the mental juggling act, that we do when we're trying to wrap our heads around a piece of code. And, working memory, that's where we hold information while we're processing it. But that has like limited space.
Mm.
Some research suggests we can only juggle about 4 chunks of information at once.
Yeah, that's right.
And you exceed that,
It all falls apart.
it all falls apart. We get confused, we make mistakes, and we spend way more time than we should just trying to figure out what the code's doing.
Right. And the source dives into some really specific examples of this, and some of them are kind of surprising, actually. So, for example, like we're always told to break our code down into smaller pieces, right?
Yeah.
More manageable chunks. But the document actually argues that sometimes that can backfire.
Okay, interesting.
They introduced this idea of deep versus shallow modules. Have you ever heard of that?
I have not, actually. Break that down a bit.
All right. So think of a deep module like a really powerful tool, but it's in a well-organized toolbox, so you know where to find it. It might have all this amazing functionality inside, but it's presented to you in a very simple, easy-to-understand interface. So you don't need to know, like, all the inner workings to use it effectively.
Gotcha. So a shallow module would be like, what, a jumbled drawer full of tools where you have to dig through everything just to, like, find what you need?
Yes, exactly. So shallow modules have simple functionality, but really complex interfaces. So there's lots of moving parts. You might have like a bunch of tiny methods or classes that each do one tiny thing, but then trying to understand how they all fit together,
Right.
it takes so much mental effort.
Yeah, that makes sense. And I think they actually use the UNIX I/O interface
Yeah.
as an example of a deep module. So this might sound a little technical for some people listening, but just bear with me. So this is basically how programs interact with files and devices on a Unix system.
Yeah.
And it's incredibly powerful. Like you can do all this crazy stuff with it, but it's all presented through this relatively small set of like really simple commands.
That's a great example because it highlights how like a well-designed deep module can hide complexity behind this like clear, concise interface.
Right.
And it's less cognitive load on the developer.
Yeah. And that principle actually applies beyond just individual modules, right? Like
Okay.
it can extend to larger architectural patterns too, like microservices.
Yeah.
So there's been this huge push towards, breaking down applications into these tiny independent services. But the document cautions against going like totally overboard with it. Like they warn against creating what they call a distributed monolith, which I think is a great term. And the example they use, and this is fascinating to me, they have an anecdote about a startup that had like 17 microservices just to handle user authentication.
It's a really common pitfall, though. People get so caught up in the hype, a new technology, and you end up creating these systems that are super complex and difficult to manage. Like, can you imagine trying to trace a bug
Oh my God.
through a system with 17 different services all talking to each other? It's like it's a recipe for a cognitive meltdown.
That's crazy. And they even draw a parallel to this, the Tannenbaum-Torvalds debate about operating system architectures, where Linux, which is, a monolithic kernel, has actually proven to be so successful.
Right.
It seems counterintuitive, but sometimes a well-crafted monolith can be more flexible and easier to maintain than like this whole swarm of like poorly designed microservices.
It's true, yeah. The takeaway here is that we have to really consider the trade-offs
Right.
when we're choosing an architecture. And sometimes the simplest solution is the most effective, especially from, a cognitive load perspective.
Makes sense, yeah. So it's not just about the size of the modules or services, it's about how they're designed and, how they interact. And that actually brings us to another interesting point. They talk about um, the potential dangers of like blindly following DRY. Don't
What?
repeat yourself.
Right, right.
Now, I'm a big fan of DRY,
Me too.
but they argue that if you take it too far, to the
Too
extreme,
extreme.
it can actually increase cognitive load.
That makes sense. Yeah.
Yeah.
DRY is important to keep your code maintainable, but sometimes a little bit of duplication is actually better than introducing these like complex dependencies
Right.
just for the sake of being super dry. Because you have to remember all those dependencies, they add to that mental effort,
Yeah, right.
to understand the code.
Yeah, they even quote Rob Pike, who he said, "A little copying is better than a little dependency." I love that.
I like that too. It's a great rule of thumb.
Yeah, but how do you know when you've crossed the line? Like, how do you find that sweet spot between DRY and just clarity?
Yeah. I mean, that's where like thoughtful design and careful consideration come in.
Okay.
So you have to weigh the benefits, right, of avoiding duplication versus like the potential cost of introducing unnecessary complexity.
Yeah.
Sometimes a little bit of repetition, can make the code easier to understand,
Right.
especially if it means you're avoiding these like convoluted abstractions.
Gotcha. So it's like we have to choose our battles wisely.
Yes, totally.
DRY is a great principle, but it's not the only
You're
factor.
not the only thing, yeah.
Right, right, when it comes to cognitive load.
And that actually brings up another area
Yeah.
where extraneous cognitive load can kind of sneak in.
Okay.
And that is the way we handle conditional logic in our code.
Oh.
So like those long conditional statements, right? With like tons of ands and ors. It's just too much for our working memory. It's like you're juggling like a dozen different factors all at once.
Yeah, I've definitely been there. Staring at one of those massive if statements.
Oh, yeah.
Just trying to trace through all the different paths.
Yeah.
And feeling my brain slowly melt.
We've all been there. But the good news is there are like simple techniques we can use to simplify those and reduce the burden.
Okay.
So one approach is to introduce what are called intermediate variables
Okay.
with meaningful names. So instead of, just having all these raw Boolean expressions,
Right.
we assign those to variables that actually like represent the underlying concept.
Okay, so like instead of having something like if user is logged in and user has permission admin and not is in maintenance mode, like that whole thing.
Right.
So
Yeah.
we could break that down, right?
Yes. So you could have something like is admin user. So that's your first Boolean. User is logged in and user has permission. And then your second Boolean would be like, is system available?
Gotcha.
Not system maintenance mode. And then, if is admin user and a system is available, then
Right. So much clearer.
it's so much clearer, right? Instead of juggling all those conditions
Yeah.
in your head, you're dealing with two named concepts.
Right. It's like translating a complex equation into plain English.
Exactly.
And suddenly it clicks,
Yep. Makes sense. Yeah, and speaking of clarity, another place we can reduce cognitive load is in our error handling. So using generic HTTP status codes, right, for specific business errors
Right.
that can create this unnecessary mental mapping that you have to do.
Right, yeah.
So the source recommends using self-descriptive error codes in the response body instead.
Okay, yeah. So instead of getting just like a generic 400 bad request response.
Right, exactly.
You might get something like invalid input, email address is already in use or something like that.
Yes,
It's
exactly.
more helpful.
It's way more helpful, yeah.
Yeah.
And this principle of like clear descriptive error messages, you can use this throughout your code,
Right.
not just in APIs, The more transparent and informative your error handling is, the less cognitive load you put on yourself and others who have to work with your code.
Okay, so we've talked about deep versus shallow modules, the dangers of overusing DRY, simplifying those complex conditionals, providing, clear error messages.
Yeah.
These are all great strategies for reducing cognitive load. But one more area I want to touch on before we move on. Inheritance. The document briefly mentions that these deep inheritance chains
Oh,
can be a huge source of cognitive load.
Yeah, navigating a deep inheritance hierarchy. It's like falling down a rabbit hole.
Yeah.
Every level of inheritance is another layer of abstraction, making it like way harder to track down, where something's defined or how a change in one class might affect others.
Yeah, it's like trying to untangle a giant ball of yarn.
Yes.
So they actually suggest composition over inheritance as like a potential solution. Can you explain that a little bit?
Yeah, so composition is basically building objects by combining smaller, more focused objects. So instead of inheriting behavior, from a parent class, you're delegating that responsibility to these like smaller, more specialized objects.
Okay.
And that can lead to a more modular and flexible design.
Gotcha. It's like building with Lego blocks. You
Exactly.
can create all sorts of cool structures
Yeah.
just by combining these simple pieces.
And each Lego block has like a clear, well-defined purpose.
Right.
It's the same thing with composition. Each component should have a single responsibility, making it, easier to understand.
Right. That makes a lot of sense. So before we move on, maybe we can just summarize some of the key takeaways for our listener so far.
Yeah, good idea. I mean, we've covered a lot, but I think the main message is that, like, managing this cognitive load is super important for developer productivity,
Right.
for code maintainability.
Yeah.
By really thinking about the complexity that we introduce both in our code and our architectures,
Yeah.
we can create systems that are, easier to understand, easier to debug,
Yeah.
easier to evolve.
For sure. Absolutely. So to recap, we've talked about deep modules over shallow ones, finding that balance with DRY, simplifying those complex conditionals, using nice descriptive error messages, and then considering composition over deep inheritance.
Right.
Oh, and we also talked about the potential pitfalls of overusing microservices and how a well-designed monolith can sometimes actually be the better choice.
Yeah.
So just a lot of food for thought.
Yeah, definitely. And in the next part, we'll get into some more of the more nuanced aspects of cognitive load,
Okay.
including the impact of language features,
Right.
frameworks, and even our own familiarity with a code base. So stay tuned for that.
So we've been focusing a lot on code structure and on architecture and stuff.
Yeah.
But what about the languages themselves that we use?
Right.
Can the complexity of a programming language itself actually contribute to cognitive load?
Absolutely, yeah. The source points out how languages that have like a ton of features,
Hmm.
while they might be powerful,
Yeah.
they can actually make it tougher to understand what's going on.
They even quote Rob Pike.
Mm-hmm.
I think it's something like when you're trying to understand complex code, you're not just deciphering what it does, but also like why the programmer chose to do it that way, given all the possible options.
Right, right.
It's like trying to read their mind
Exactly.
through the code.
And that mental, like, reverse engineering process can be really taxing.
Yeah.
Especially if the code is using, like, obscure language features
Right.
or unconventional syntax. Like,
Yeah.
imagine trying to decipher code that's heavily reliant on operator overloading or template metaprogramming in C++ner.
Yeah.
Like, oh my goodness.
And they even share this anecdote. I think it was like a seasoned C++ engineer with like 20 years of experience.
Oh, wow.
And he admitted to feeling overwhelmed
Yeah.
by the sheer number of features, just how complex that language has become.
Right. And I think that anecdote really highlights that even really experienced developers, they
Yeah.
can still struggle with this.
Right.
It highlights how important it is to choose a language that has that balance between expressiveness
Right.
and clarity.
So it's not just about like learning the language, it's about learning like all the nuances and idiosyncrasies
Those weird little quirks.
that come with it and like keeping up with it as it evolves.
Right. And that brings us to an important distinction.
Okay.
So intrinsic cognitive load versus extraneous cognitive load. So intrinsic is inherent to the problem that you're trying to solve, like that essential complexity.
Okay.
You can't avoid it.
Gotcha. So like if you're building a complex financial trading system,
Yeah.
there's going to be like a certain level of like inherent complexity no matter what.
Exactly. Yeah. But extraneous cognitive load, that's like the stuff on top.
Wait, check
It's
that.
the unnecessary complexity. That's what makes things hard.
Okay, gotcha. So going back to our C++ engineer,
Yeah.
learning like the core concepts,
Mm-hmm.
like object-oriented programming, that would be intrinsic.
Right.
You got to learn that.
You can't get around that.
Right. But then keeping up with every new feature, every new language quirk, that's extraneous.
That's extraneous. Yeah.
Right. It's mental baggage you don't really need.
Right. Yeah.
And this distinction, it's important to keep that in mind when we evaluate different tools and technologies.
Totally.
So, we should always strive to minimize extraneous cognitive load,
Yes.
whether it's in language or the frameworks we use or just the way we structure our code.
100%. Yeah.
Speaking of frameworks,
Mm-hmm.
the source also kind of dives into the potential pitfalls of relying on those too heavily.
Oh.
While they can be useful for bootstrapping a project and giving us all this built-in functionality, they can also introduce their own cognitive load.
Right, yeah. They have that, that magic to them,
Right.
where things are just kind of happening behind the scenes,
Yeah.
but you don't really understand how. And it can take time to really learn all those intricacies.
Right.
And if you're not careful, you can end up like really tightly coupled to
Yeah.
that framework. And then it's hard to change it later.
They recommend treating frameworks more like libraries, using them for like specific tasks
Yeah, I like that.
instead of letting them dictate like the whole structure of your application.
I agree. That way you maintain more control
Right.
and you avoid that, that vendor lock-in.
Yeah. Yeah. You don't have to like fork it and maintain your own custom version later.
Exactly, yeah.
And that actually makes me think about this whole idea of convention over configuration,
Oh, yeah.
which a lot of frameworks tout as like a benefit.
Right.
But sometimes like too much reliance on convention
Yeah.
can actually lead to a lack of transparency.
Yeah, it can be hard to like trace what's actually happening
Yeah, right.
because it's all kind of like magically wired together.
Yeah. If you're trying to like debug or make changes,
Right.
it can be really frustrating.
And it's not just understanding how the framework works, it's like the mental overhead
Yeah.
of remembering all the components
Yeah.
and configurations and dependencies.
Right. It's like learning a whole new language
Exactly.
just to use this one tool.
Yeah, and then if you're like switching between different frameworks all the time,
Oh, yeah.
that cognitive load just, it adds up.
The document actually suggests that getting junior developers involved in code reviews
Oh, interesting.
can be like a really surprisingly effective way to identify areas of high cognitive load.
Yeah, that makes sense because fresh eyes,
Yeah.
they can often spot things like complexities that we've just become blind to.
They even quote Dan North. I think he said something like, once you've internalized the mental models of a project, you no longer experience that cognitive load
Right.
that those models impose on others.
It's like riding a bike.
Yeah.
Once you learn how to do it, it's like effortless.
Right.
But that doesn't mean it's easy for everyone.
It highlights the importance of like empathy in software development.
Totally.
We need to think about the cognitive load we're putting on others,
Absolutely.
not just ourselves.
And this whole discussion about frameworks, it reminds me of another area
Yeah.
where we can introduce extraneous cognitive load. And that's the way we interpret and apply DDD,
Driven design.
domain-driven design. Yeah.
Right.
So it's all about modeling your software to like reflect the real world, right?
Yeah.
But the source cautions against overemphasizing specific DDD techniques
Okay.
if it's at the expense of clarity.
Gotcha.
Like some developers get really hung up on certain folder structures or naming conventions
Right.
Yeah. because of their interpretation of DDD,
Right.
even if it doesn't actually make the code easier to understand.
It's like prioritizing the appearance of the code over the substance.
Exactly, yes. You
Yeah.
end up with like this code base that looks really DDD compliant,
Right.
but underneath it's still just as complex.
They really stress focusing on the core principles of DDD,
Yeah.
like understanding the domain, building a model that reflects that
Right.
rather than getting bogged down in like all these specific techniques
Yes.
that might not be universally understood.
And that principle applies beyond BDD.
Right.
We always have to think critically
Yeah.
and question if the tools and technologies we're using, are they actually helping us?
Right.
Or are they just adding complexity?
It's like being a chef.
Yeah.
You don't just blindly follow a recipe.
Right.
You got to understand the ingredients,
Yeah.
the
Yeah.
techniques,
Yeah.
what you're actually trying to create.
You got to adapt. And just like a chef, who's trying to make food that is both delicious and visually appealing, we should aim to write code that is both functional and cognitively efficient.
Okay. So we talked about the cognitive load of these complex languages, the potential pitfalls of frameworks, the importance of applying DDD, carefully. One more area before we wrap up this part.
Okay.
This concept of the familiarity trap.
Oh, yeah.
Do you-
Familiarity trap.
This is a subtle one, but it can really get you.
It's that tendency to like underestimate the complexity of something just
Yeah.
because you're familiar with it.
Yeah, so like I might have been working on this code base for years and I know it inside and out.
Yeah.
To me, it seems totally straightforward.
Yeah.
But then a new developer comes on the team.
Right.
And to them, it's like this impossible maze.
Right. Exactly. And we develop those mental models that
Yeah.
let us like navigate that code base
Right.
efficiently,
Right.
but they're not transferable.
It's like walking through your own house in the dark.
Yeah.
You know exactly where everything is, so you don't bump into anything.
Yeah.
But someone who's never been there before,
Right.
they're going to be tripping over everything.
Right. Exactly. Yeah, and that's why it's so important to be aware of the familiarity trap.
Yeah.
We need to step outside our own heads
Right?
and try to see it through someone else's eyes.
And that's where things like code reviews and pair programming can be so
Oh,
helpful.
totally. Yeah, you get that feedback.
You're sharing that mental burden,
Exactly.
and you're catching those potential errors before they become big problems.
It's like having a co-pilot.
Yeah.
You can share the workload, you can look out for each other.
The source also highlights clear communication,
Oh, yeah.
both within the team and with people outside the team.
That's so important. Because miscommunication, that can lead to all sorts of problems.
Oh, yeah.
Wasted time, buggy code, frustrated users.
Like, if you can all speak a common language,
Yeah.
it just makes things so much easier.
Exactly. And that applies to everything, like user stories,
Yeah.
acceptance criteria,
Code comments,
code comments, yeah,
commit messages.
commit messages, yeah. The more clarity we can bring, the less mental energy we have to spend figuring things out.
Okay, so we talked about writing clear and concise code, breaking down complex tasks, collaborating effectively, communicating clearly. Is there anything else we can do at like a higher level?
Yeah. The source really emphasizes the importance of choosing the right architecture,
Okay.
the right frameworks, the right technologies for the problem you're solving.
Yeah.
It's easy to just grab like the latest, shiniest tool,
Right.
but sometimes all that complexity, it's just not worth it.
It's like using a sledgehammer to crack a nut.
Exactly.
Yes. And they even suggest, sometimes a simple, well-structured monolith
Yeah.
can be better than a complex microservices architecture.
Totally.
So it's about making these conscious choices
Yes.
that prioritize clarity, simplicity, and maintainability,
Mm-hmm.
not just for us, but for everyone who's going to be interacting with our code.
Yeah. And remember, it's an ongoing process.
Right.
Cognitive load, it's something we have to think about throughout like the entire life cycle of our software.
Right, from the very beginning all the way through.
Exactly.
Well said. So as we wrap up this part, I want to leave you with this. Think back to a time when you were just like totally confused or overwhelmed working on a project.
Yeah.
What were the things that led to that overload? Was it complex conditionals or deep inheritance or a confusing framework
Right.
or maybe just like poorly documented requirements?
Yeah, and how could you have addressed those?
Yeah, how could you have made it more manageable?
Exactly.
It's something to think about, not just for us,
If-
but for like the whole software development world.
Totally.
If we can all learn from each other, we can create a world where software isn't a source of frustration,
Yes.
but it's like a tool for empowerment and innovation.
I love that. Thanks for joining us for this part.
Yeah, we hope it's been insightful. And remember, cognitive load is what matters.
Okay, so welcome back to our deep dive into cognitive load. We've covered a lot of ground, complexities of code structure, architecture,
Yeah.
the nuances of language features, frameworks, even, how our own familiarity can actually make things worse. But like, what can we actually do about it? How can we apply all these ideas and actually build better software?
Yeah, that's the million-dollar question, right? And thankfully, this document doesn't just like leave us hanging with a bunch of theory.
Mhm.
They actually offer some really practical advice.
Okay, good. Give us the goods. Like, what can we start using right away?
So one of I think the simplest but most effective techniques is just focusing on clarity, being concise in our code. I mean, this seems obvious,
Yeah.
but you'd be surprised how often we get kind of caught up in these clever solutions
Yeah.
or convoluted logic that ends up just obscuring what we're trying to do. Oh, I totally been there. Like trying to be too clever or over-optimizing something, and then like later I realize it's just a nightmare to understand.
Exactly. The document, it emphasizes writing code that's easy to read, easy to understand. Even for somebody, who's never seen the project before, think of it like writing a clear and concise email.
Gotcha.
Get your point across.
So it's like prioritizing clarity over cleverness.
Yeah.
Kind of writing code that's more like a well-written essay
Yeah,
than like a cryptic puzzle.
exactly. And this applies to everything. Choosing good variable names, good function names,
Yeah.
structuring your code in a way that's logical,
Right.
easy to follow.
And I think they also talk about like using comments strategically, explaining the why.
Yeah, that's a good point. Comments can be super helpful, to give context, explain why you're doing something, especially if it's not like immediately obvious, but you shouldn't overdo it.
Right.
Too many comments, it's actually more cognitive load.
Right. It's like adding too many footnotes.
Hmm.
A few are good.
Exactly.
But if you've got like a footnote on every other
It's
sentence
too much.
is too
Love
much.
that.
Another technique, and we kind of touched on this earlier, is breaking down those complex tasks into smaller steps.
Yeah, smaller, more manageable chunks.
Right.
This applies to how we work too. Not just the code.
So instead of trying to like tackle this huge feature all at once,
Yeah.
you just break it down.
Exactly. You can focus on one thing at a time. It's easier to track your progress. You can see those roadblocks coming, get feedback along the way.
And speaking of feedback, they talk a lot about collaboration and code reviews, right?
Oh, yeah. It's so key. We can get so stuck in our own heads. When you're coding,
Yeah.
you develop blind spots.
Right.
You make assumptions.
And you don't realize it.
But when you work with other people, get feedback, you can expose that hidden complexity
Right.
and just make your code better overall.
It's like having a second pair of eyes,
Yeah.
to proofread your work.
Yeah.
And code reviews, they're not just for finding bugs. It's also about sharing knowledge.
Yeah, discussing approaches, learning from each other.
And it even suggests bringing in, like, junior developers.
Yeah, I love that idea.
Because they can spot things
They have fresh eyes.
that we just don't see anymore.
Totally.
And pair programming can be really great for that, too. You're working together in real time. You can share that mental burden.
Yeah.
You can brainstorm together, and again, catch those errors early on.
Yeah, it's like having a co-pilot in the cockpit.
Yeah.
You share the workload. You watch out for each other.
Speaking of which, they also talk about clear and consistent communication,
Yeah.
not just within the team, but also with people outside the team,
Right.
like stakeholders.
Yeah.
That's so crucial because miscommunication can cause like all sorts of problems.
Oh, yeah, wasted time.
Buggy code.
Frustrated users.
So if we can all like speak a common language,
Yeah.
it eliminates so much confusion.
Exactly. And that means everything. User stories, acceptance criteria,
Code comments.
commit messages. The more clarity we can bring to our communication, the less mental energy we have to spend figuring things out.
Okay, so we've talked about writing clear code, breaking down complex tasks, collaborating, communicating clearly. But is there anything else we can do at like a higher level in terms of our overall approach to software development?
Yeah, they stress choosing, architectures, frameworks, and technologies that align with the problem you're trying to solve.
Okay.
It's so tempting to just grab the newest, coolest thing,
Yeah.
but sometimes that complexity just isn't worth it.
It's like using a sledgehammer to crack a nut.
Exactly.
And this applies to everything. The programming language,
Yeah.
how we structure our data,
Right.
how we deploy our applications.
Right. It's all about those trade-offs,
Yeah. And they even suggest, sometimes a simple, well-structured monolith is better.
Than a super complex microservices architecture.
It's about resisting that urge to over-engineer things.
Yeah.
Sometimes simple is best.
Absolutely.
So it's making those choices, prioritizing clarity, simplicity, maintainability.
Yeah.
Not just for us, but for everybody, who's going to touch our code.
Yeah. And remember, managing cognitive load, it's an ongoing thing.
Right.
We got to be mindful of it throughout, the whole process, from the very beginning to the very end.
Right, from design all the way through maintenance.
Exactly.
Well said. Well, this has been a really fascinating deep dive.
Yeah, it has.
We hope it's been helpful for everyone listening.
Me too.
And, remember, cognitive load is what matters.
Yeah.
Thanks for joining us.